Pipeline infrastructure plays a critical role in energy delivery and economic continuity. These pipelines often extend across long, remote corridors where ground conditions can change over time. What happens along the pipeline right-of-way directly affects pipeline integrity. Ground movement, erosion, or slope instability within the ROW can introduce stress, exposure, or failure risks to the pipeline itself. Traditional monitoring approaches struggle to provide consistent visibility across these large areas. Because of this, drone technology now offers a new way to monitor pipeline ROW conditions more effectively. In the following sections, we explore how drones support geotechnical monitoring along pipeline corridors, the challenges they address, the benefits they provide, their limitations, and how this approach is shaping the future of pipeline integrity management. Pipeline right-of-ways often pass through hilly terrain, river crossings, forests, and environmentally sensitive areas. These locations are exposed to natural processes such as erosion, settlement, and slope movement. Geotechnical changes usually develop gradually and may not be immediately visible from ground level. Without regular monitoring, early warning signs can be missed. Limited access, difficult terrain, and infrequent inspections make it challenging to maintain continuous awareness of right-of-ways conditions. As a result, these challenges highlight the need for a monitoring approach that can provide consistent, wide-area visibility over time. Traditionally, pipeline ROW monitoring relies on manual inspections. Field teams conduct foot patrols or vehicle-based surveys along accessible sections of the corridor. While these methods have been used for many years, they are labour-intensive and time-consuming. Inspections are typically periodic rather than continuous, leaving long gaps between assessments. In remote or difficult terrain, manual inspections also increase safety exposure for personnel and drive higher operational costs. These limitations make it clear that an alternative approach is needed. Drones introduce a new paradigm in pipeline ROW monitoring. By taking inspections to the air, drones provide rapid access to long pipeline corridors without the physical constraints of ground patrols. They can be deployed quickly, operate over difficult or hazardous terrain, and cover large areas in a single flight. This aerial perspective allows operators to observe ROW conditions that may be difficult or impossible to assess from the ground. To understand how this works in practice, it is important to look at how drones collect data along pipeline corridors. Drones monitor pipeline ROWs using a combination of sensors and structured flight planning. High-resolution cameras capture visual information, while LiDAR sensors measure terrain elevation and surface changes. Planned flight paths ensure repeatable coverage along the same corridor sections over time. The data collected provides detailed insight into surface conditions, slope stability, erosion patterns, and ground deformation. This capability leads directly to several key operational benefits. One of the key benefits of drone-based ROW monitoring is speed. Large sections of pipeline corridor can be inspected in a fraction of the time required by manual methods. Safety is also improved as drones reduce the need for personnel to access steep slopes, riverbanks, or remote areas. Over time, operational costs are reduced through fewer field deployments, better planning, and earlier identification of geotechnical issues. However, the value of drone monitoring increases even further when data is analysed over time. The true value of drone monitoring is realised when data is analysed over time. Artificial intelligence and data analytics enable large volumes of drone data to be processed efficiently. By comparing datasets from multiple inspections, Engineers can identify patterns, detect changes, and highlight anomalies along the right-of-way. This approach supports predictive maintenance, allowing potential issues to be addressed proactively rather than reacting after problems occur. These capabilities are already being applied in real-world pipeline environments. Drone-based monitoring is especially valuable in challenging environments. In hilly terrain, drones help identify slope movement and landslide risk. At river crossings, aerial surveys support erosion monitoring without disrupting operations. For remote pipelines, drones provide consistent visibility that would otherwise require significant manpower and complex logistics. Despite these advantages, drones also have practical limitations. Despite their advantages, drones also have limitations. Flight time is constrained by battery capacity, requiring careful mission planning. Weather conditions, such as strong winds, heavy rain, or thunderstorm, can affect flight safety and data quality. Regulatory requirements may restrict flight altitude, range, or operating locations. For this reason, drone monitoring is evolving toward greater automation and system integration. The future of pipeline ROW monitoring is moving toward greater automation and system integration. Advances in autonomous drone operations will allow routine inspections with minimal human intervention. Integration with satellite data, ground sensors, and centralized monitoring systems will provide a more comprehensive view of pipeline health. Together, these developments will enable continuous, scalable, and predictive monitoring across entire pipeline networks. This evolution brings us to the key takeaways. Drone-based geotechnical monitoring represents a major advancement in how pipeline ROWs are observed and managed. By combining aerial access, advanced sensing technologies, and intelligent data analysis, operators gain clearer visibility across long corridors, earlier identification of geotechnical risks, and safer inspection workflows with reduced field exposure. As pipeline networks continue to expand and operating environments become more complex, intelligent monitoring solutions will play an increasingly important role in maintaining pipeline integrity, safety, and long-term reliability. Thank you for watching. We hope this overview has provided valuable insight into how drone-based monitoring is transforming pipeline ROW geotechnical management.